Hello everyone, good morning. This is Mr. Dakshinhaamooorthyi, AP-AIML department. Today's topic is actor critic algorithm in Unit 4 function approximation. Actor critic algorithm. In the previous chapter, we discussed about only policy based or only with value based. When we are working with the continuous huge amount of input environment, there we are using the hybrid model, actor critic model. Actor critic algorithm is a type of a reinforcement learning algorithm that combines aspects of both the policy based methods for actors, value based methods for critic. This hybrid approach is designed to address the limitations of each method when used individually. In the actor critic framework, an agent, the actor learns the policy to make decisions, and the value function, the critic, evaluates the actions taken by the actor. Simultaneously, the critic evaluates these actions by estimating their value or quality. This dual role allows the method to strike a balance between exploration and exploitation, leveraging the strengths of both policy and the value functions. In this diagram, the agent it contains two portions. In the earlier diagram, we seen only the environment and the agent alone. Here the agent portion itself contains two types. One is actor, another one is critic. Here actor is working on the policy based and the critic is working on the value based method. And once the action is performed, the environment is giving this is observed by the critic, and it is evaluating the value for the particular action and giving update to the actor network. In this diagram, we can clearly see actor and critic within the agent. Here actor is control policy mu based and critic is q value function. Once the actor is taking action on the environment u, and this particular for this action, what is the value, evaluated value, which is given to the actor such a way that it is governed by the critic. Here key components of reinforcement learning. Before delving into the actor critic method, it is crucial to understand the fundamental components of reinforcement learning RL. The agent, the entity making decisions and interacting with the environment is the role of agent. Environment is the external system with which the agent interacts. And state, a representation of the current situation or the configuration. Action, the decision or move made by the agent. Reward, the feedback received by the agent based on its actions. Policy, the strategy or set of rules guiding the agent's decision making. Roles of actor and critic. Actor, the actor makes a decision by selecting actions based on the current policy. It is responsibility lies in the exploring the action space to maximize expected cumulative rewards. By continuously refining the policy, the actor adapts to the dynamic nature of the environment. Critic. The critic evaluates the actions taken by the actor. It estimates the value or the quality of these actions by providing feedback on their performance. Critic role is pivotal in guiding the actor towards actions that lead to higher expected returns, contributing to the overall improvement of the learning process. Actor critic algorithm objective function. The objective function for the actor critic algorithm is a combination of the policy gradient for the actor and the value function for the critic. The overall objective function is typically expressed as sum of the two components. One is the policy gradient actor. Here gradient of j theta, that is gradient of objective function, is approximately 1 by n into summation I is equal to 0 to n gradient theta into logarithm of pi theta of ai given that si into a of si and comma ai. J theta represents the expected return under the policy parameterized by the theta. Pi theta of a given that s is policy function. N is the number of sampled experiences. A of s comma a is the advantage function representing the advantage of taking action a in the state s. I represents index of the sample. Actor update pi theta plus 1 theta t plus 1 is equal to theta t plus alpha gradient theta into objective function j of t theta t. Here alpha is the learning rate for the actor, t is the time step within an episode. Value function update in the critic side. Gradient w j of w, that means objective function, is approximately 1 by n into summation I is equal to 1 to n gradient w into vw of si minus qw of si comma ai the whole square. Here gradient w into j of w is the gradient of loss function with respect to the critic's parameter w. N is the number of samples. Vw of si is the critic estimates of value of state s with parameter w, and qw of siai is the critic estimate of the action value of the taking action a. I represents the index of the sample. And critic update wt equal to wt minus beta into gradient w into j of wt. Here w represents the parameter of the critic network, beta is the learning rate for the critic. Advantage actor critic A to C is the specific variant of the actor critic algorithm that introduces the concept of the advantage function. The function measures how much better an action is compared to the average action in the given state. By incorporating this advantage information, A to C focuses the learning process on actions that have a significantly higher value than the typical action taken in this. Advantage actor critic A to C is a specific variant of the actor critic algorithm that introduces the concept of the advantage function. The function measures how much better an action is compared to the average action in the given state. By incorporating the advantage information, A2C focuses the learning process on actions that have a significantly higher than the typical action taken in the state. While both leverage the actor critic architecture, here's a key distinction between them. Learning from the average, the base actor critic method uses difference between actual reward and the estimated value. Critics evaluation to update the actor. Whereas in the learning from advantage function, A2C leverages advantage the function, incorporating the difference between action value and the average value of the actions in that state. Additional information refines the learning process further. Thank you.